All right, cool. Whoa, I had 0 people here, and now there are 3 people here. That's hilarious. Hey, all right, we're gonna get started. I guess I'll just get started now. Hope you're doing well. My name is June. I am a software engineer at a place called P2BI here in Denver. It's a financial tech startup, and just thought we'd go over some JavaScript array prototype stuff. So if you're here to learn that, you're in the right place. You're going to want to go ahead and check out my GitHub. It's going to be github.com/Joshua June. It should have been in the invite, kind of showing you how to what to download or what to clone. And so if you're going to clone that down, it's going to be here, this JS array practice thing. If you don't have Git set up on your computer, it's going to be kind of difficult for you to get started. So what I would definitely encourage you to do is kind of install this onto your computer. This might be more of a watching session than like a code along session for you. But what we're going to be going over today is a thing called reduce. Now, one thing that I've been doing lately is just kind of walking folks through like just basic programming. Now, one thing you're going to be doing often and doing a lot of is you're going to be doing it's so weird. Why? Such a weird thing there. You're going to be doing a lot of moving through data types and collections of data. So the more you understand and the more you're comfortable with just, hey, Jason Lopez says hi. Hey, Jason. The sooner and more confident you are in kind of moving through collections of data, the better and easier your life is going to be. So one of those things we're going to be going over is a thing called reduce. Initially, for most of the people I've taught, this typically is something that's a little challenging initially. It's kind of hard to wrap your mind around, but if you kind of understand the gist of it, what you're essentially doing is you are moving through each index inside an array. So when I say index, arrays are data types, and all they really care about are not necessarily what data it's holding, but the way you access that data is via the index or the place in which that data sits. So like if you were to think about it at like a classroom, so like if you remember maybe like your favorite teacher in middle school or high school, like the teacher that didn't necessarily care where you sat, but just made sure that your seat was filled. That's kind of like an array. All an array really cares about is like where the position of that data is, not necessarily the value of that data. So if I were to go back into the console here and declare an array, it's a const like numbers. I said 1, 2, 3, 4. And now I have my numbers array, and I were to grab the first value in that array, you're going to access that value by index. And so what you do is you typically hit it with 2 brackets, and you say what part of the array you want to go to. And so here, I'm going to hit 0, meaning the first thing in that array. So I get 1. Now when I go 1, I get 2, and so on and so forth. And so what reduce allows us to do is it's essentially going to move through the array much like how I'm doing it here, getting each value within that list, right? It's kind of like a list, first, second, third, fourth value, but it's also going to allow us to change the value of what's inside that array. So for instance, what if I wanted to add all these integers or numbers together? I would use something like a reduce and just kind of smash all those numbers together. And kind of like what we talked about last week, we went over filter if you were here. Filter, and just like map, what it does is it returns a new copy of this array, right? Because the last thing you want to do is change your source of truth. If you have other pieces of logic or code that are looking to your array for some source of truth, and you manipulate that source of truth, that's going to kind of trickle down the stack and kind of make unwanted changes where they probably shouldn't be, right? And so what this does for us is it allows us to kind of make those changes, but allows us to keep this thing intact. So just like any sort of iterator into JavaScript, I say numbers, and I say like what array prototype method I want to use. And if we look here, reduce just kind of tacks onto the end of that array, right? So if I wanted to reduce over that, I would say array, or the thing that I want to reduce over it, and then I would pass in a callback, right? Now what's interesting that's different between this and like map or filter is that it takes an extra parameter, and it's going to be the accumulator. And all the accumulator is going to be is like, what is our starting value going to be? So if we were to go back to our previous example here, if I want to reduce over these numbers, right? So if I said I wanted to add everything together, right? So we're using our math here. 2 plus 1 is 3, 3 plus 3 is 6, and then we would get 10, right? So the outcome of this reduce should be 10 if we're going to be reducing over it. So what if I said const like sum, and then here I said numbers dot reduce, right? And so like we kind of talked about, it's going to take a callback. So we have a callback. Right, so here's our callback, and all a callback is a fancy word for like a function, right? And what that is going to take next is, notice I comma separated it, is going to be like our starting value, and it should be 0 because I'm going to be adding to 0, right? So here we have kind of the inner workings of our reduce, right? And so here I would be like, cool, accumulator. Or what if I said sum? So the first argument would be like what the value of sum is. In our first initial case, it's going to be 0. And the next thing is going to be like our next value, right? Or next number. How about that? And with anything inside of any array prototype method, you want to return a value. So we return something here. I'm going to return the sum plus the next number, right? So I hit return, and I ask for sum, it should be 10, and it's 10. Because essentially what it's doing is it's going through and it's like redefining those values. So if we were to run this again, so I'm going to refresh this. Run this again. Let me redeclare everything. And I threw a debugger in here. Oops. Let's try that one more time. Man. Numbers. And I threw a debugger in here. And I run this, you're going to see that our initial value of sum is going to be 0. So if I call sum 0, I call next number should be 1, right? And so what we're doing is we're adding those things together. So if I go on through the next part of this like loop, our sum now should be 1, right? Because our accumulator now changes, right? What our initial value is no longer 0, it's now 1. Right? So I say sum, and the value should be 1. It is. And our next number should be 2. Cool. Do it again. Now it should be 3, should be our sum. Right? Cool. And our next number should be 3 as well, which would then lead us to go to 6. So our sum now is 6. Right? And our next number is 4. Cool. So like so on and so forth, and just kind of mashes those things together. So that's what reduce is doing. And so what we're going to be doing today in particular is I've written some tests about reduce that we can use to like kind of help us understand that more. Feel free to ask questions here. I'm going to type some in here if you have any questions. Ask them here anytime. Cool. So we are in our tests. So if you're new here, essentially what we're doing is we're declaring what we want. So here I'm saying I'm looking for a thing called results, a variable called results, and its value should be 473, right? So first thing we're going to do is we are going to unskip this test. So I just did that there. The next thing I want to do now is I want to declare that variable, right? So here I'm going to say const results because it's looking for that value of results, right? So what if right now I just said results is equal to 0, and then I were to run my tests, npm test reduce. I'm expecting the error to say expected 0 to equal 473, and that should be the error, right? And And sure enough, that's what it says. Assert expected 0 to equal 473. It's looking for this variable of results. It finds it and says, hey, I was expecting this to be 473. You gave me 0. So what we want to do is we want to kind of change that, right? We know that's the error. Now it's kind of leading us towards the answer, right? So the next thing we need to do is begin to like use that logic we kind of talked about with reduce, right? We want to define an accumulating value, or our initial value, loop through our array. When I say loop through, I mean like move through the indexes within our array, and then kind of add them together, right? So here, if I go into numbers, so I'm gonna take the numbers array. I want to reduce over that numbers array, right? Again, takes a callback, so I'm gonna put my callback right here. Now, one thing like we talked about that's different about reduce is that it takes an initial value, right? So that becomes our accumulator. And so here our initial value is going to be 0, right? And it might make sense for us to say here, oops, oh, sorry, my text editor. It's hard to talk and type. Here I'm going to say it's sum, right? And then here I'm going to say next value. Makes sense, right? And here I want to return the sum plus the next value that's coming through, right? So the first value that's going to come through is going to be 32, right? So this will be 32. Our sum right here is going to be 0. We're going to add it together. 32 plus 0 is 32. The next number we get is going to be 1, right? And after we get 1, 32 plus 1 is 33, right? And then 33 plus 21, and so on and so forth. So what we want to return here is sum plus our next value. Let's see if that test passes. Cool. Looks like it passes. Looks like I got a scraggler test down here. Don't want you to look at this. We're going to go over this later. Let's skip that. Cool. All right, let's move on to the next one. Also, if you have any questions, please feel free to drop them at the bottom. If I'm going too fast, you want some clarification about anything, like please ask them at the bottom. Cool. So if we're doing this here, kind of the same thing. We're going to say const results, right? And we're going to reduce over our numbers array, right? Actually, let me go to line 9 real quick and let's fix that. Cool. So we are now reducing over. It takes a callback, right? What's nice about the callback is that it's going to help us kind of get to our answer. Here, I'm going to say your next value is going to be 0. So we should be subtracting from 0, right? Which is why we get a massive negative number. Also, one thing I did want to talk about real quick before we moved on is you're seeing I'm constantly adding a return here. Now, if that's really annoying, ES6 gives us this fat arrow, right? And what's really like powerful about this fat arrow is that it has an implicit return, meaning I don't necessarily have to say return every single time if I keep it on one line. So here, instead of returning like this, I can simply have it return on one line like this, and this should still work. So if I go ahead and skip this real quick and I run this again, this should still pass, and it does. Cool. That's the really cool part about like tests, is that when you want to make a small change, you have a source of truth to kind of check against, right? So we have that now. We have this going. This looks good. Maybe for our rhythm today, we'll start with like the explicit returns and then move towards more of the implicit returns, because that might be a little more helpful for you to see what's actually going on. So here we have that. I know I want to return something, right? Here, I believe when you're removing something, it's now a remainder, right? If anybody wants to fact check me on that. What's up? Oh, just looking at the chat here real quick. Seeing what people have to say. Clay, what's good, man? It's good to see you. I hope this is helpful. If you have any questions, feel free to drop them into the channel, or into, not the channel, the chat, and we'll kind of keep it moving. So we have our remainder. I know I have my like next value, right? That's the next thing. So that's looking good. I'm liking that. I want to take our remainder and essentially minus the next value, right? That's what I want to return. And judging by that, I'm assuming this is gonna pass. I was never good at math, and it's ironic that now I write software for a living because it doesn't really make any sense. Ooh, looks like it's skipped, so let's go here. Oops, let's do that. Cool. Let's run the test. That should pass. Ooh, oh, didn't save it. That's important. Oof. Looks like expected. I wonder, is my math correct? I wrote these tests and I'm assuming the math is not correct. I'm gonna go with that. I'm gonna say the math is not correct and it's actually 170. Told you, I admitted right off the bat that my math is bad. That should pass. Cool. Man, my middle school math teacher would be so disappointed in me. So disappointed in me. All right, the next one, it looks like our initial value is going to be 1. And our code goes here. Cool. So kind of the same thing. Results. And we're going to say numbers.reduce. And here, kind of the same thing. Oh, real quick, we need to refactor this. So let's go ahead and get this on the one line. Right, and let's just remove that. And now we have everything on one line. Let's see if that works. It's going to yell at me because I skipped this test, so let's go ahead and unskip it. Ooh, whoops. And let's run this again. Why? It's funny, man. What am I doing? No? There you go. Okay. Linux, man. Cool. npm test reduce. Oof. Looks like I ran into an error. I think it's probably because this semicolon shouldn't be here. Pretty sure that's what it is. Oof. Let me check my math. Remainder next to value. Let's actually read the error. Hold on, I can't read the error, unfortunately. Results, number, reduce, remainder. That looks good. Let's try one more time. Not that I actually fixed anything. I don't know what it's mad about. Oh, let me see. That's why. That looks good. That looks good. Anybody spot the error? Anyone want to help me out? I think I might have hit a snag here. Remainder. What I'm gonna do real quick, because I can't really see what the error says. Unfortunately, I'm using a thing where I can't what is it? I can't use my mouse, so like I have to scroll up and it won't let me scroll. So let me run the test. And let me see what the actual error says. Cool. Because of line 23, basically. That's why. So let me get rid of that. This should work now. Oops. Man. Cool. Now it works. Okay, cool. Not a bum. Sweet. So we have that working. So that works. Thanks for being patient with me. Let's see. Yeah, Clay says scroll. My buddy Clay says scroll. I'm pretty stoked about that. I really appreciate you trying to help me out here. Let's multiply the next thing. So I'm going to say const results equals numbers dot reduce. We're going to take our stuff here. Our initial value should be 1. Right. Now we should take our product. Is it product? Is that what it is for multiplication? I'm gonna go with that until somebody tells me in the chat that I'm incorrect. I'm gonna go with product. I'm gonna say next value here. And now what I want to return, kind of very similar, is return the product multiplied by the next value, right? Let's see if that works. Produce. Thank you. Spelling is probably the hardest part of all of this, to be honest with you. +1. Mark Miranda's here. What? Hey, Mark. What's going on, bro? Good to see you. I don't know why you're here. You're way too good for this. You're like, you know how like when people are like overqualified for something? That's my buddy Mark Miranda. He's here. Don't know why he's here. I appreciate the support though. If you like want to get, you know how like people have like posters of like, you know, when you're like trying to work out and like have a bodybuilder, right? You want to be like a bodybuilder. You have like a picture of a bodybuilder on your wall or something, right? Like I have a picture of Mark Miranda on my wall because I just want to be him. He's so good at life. Anyways, we've got that happening. So let's go ahead and refactor this now to one line. Just one small line here because we won't need that anymore. Cool. So let's see if that works. Boom. Works. Cool. Mark Miranda with the Filipino flag. I appreciate it, bro. So one thing I like to do, so syntax is kind of everything, right? So when you write code, it's typically for people first. What you want to do is to make sure that your code is like somewhat legible, right? It'd be like if you were reading somebody's paper, read a blog post, and there was like no punctuation, no sort of like spelling, like it'd be really hard. And so typically what you want to do is kind of declare your variables up here, and then your expectation, there should probably be like a line in between it, just because you want to be like really explicit about like what you want to get out of the test. This is the most important piece of your test, right? Like this is what you're comparing everything else against, and so that's what you want to do. So this one looks like a lot of fun. We want to subtract the smallest number. So here we have arrays of arrays. Don't let that intimidate you, okay? Don't let that intimidate you. And our initial value is going to be 100. So cool, appreciate that. Let's go ahead and say const results. Now before I start typing here, I just kind of want you to think about like the process of like solving this here, because that's gonna be really helpful to like kind of think through that. Because what we really want is the smallest value inside of this array, right? So if we're looking at this, we want to grab the 3, right? That's what we want here. If we are kind of moving on from that, the next thing, we want a 1, right? Then we want the 2, and then we want the 6. So there's some things that we have to like kind of think about to get this done. So here, let's just get it going. I'm gonna say elements. I'm gonna say reduce, right? Gonna give this an initial value of 100, I believe, and we want to subtract everything by the smallest number, right? So some things to think about, like so product, I think it's remainder, right? And we'll say collection, because it's really a collection of numbers, right? So let's call it a collection. So here, what we want to do is find the smallest number in our collection, take that number and minus it from the like initial value. So kind of for you, if you're thinking through this, I want you to think through about like how do I say this in English before I actually like go and like solve the problem, right? So one thing I want to show you that's gonna be really helpful for us in finding the smallest number is this thing called math.min. Okay, math.min is basically going to take a collection of numbers or whatever numbers you feed it, like this, right, as arguments here, and then kind of shoot out math.min. Now what's really nice here is this thing right here, this ... is a thing called the spread operator, where it's essentially going to take an array or a collection of things, whether it's an object or an array of values, and just like kind of send them off one at a time into like into this function here, just kind of like that. So that's what we're going to use. So really what we can say here is we can say like let smallest value equal math.min, right? And what I want to pass through here is our collection. Right, so now I have my smallest value, and what I want to return now is going to be the remainder minus the smallest value. So theoretically, this right here is going to give us 3, right? 1, 4, and 6. Okay. So Clay here is saying he struggled with the spread operator a lot. I think that's true. I think for a lot of folks who are getting into JavaScript, this right here, this ... syntax that you're seeing might seem a little confusing until you actually like go and play around with it, right? And so maybe it might make sense for us to kind of hop in and poke at the code. So what I'm going to do here is I'm going to go ahead and kind of humanize it by letting us like debug. So here I'm going to run the test. I'm now inside line 32, right? Actually, I'm like right at like line 31, kind of, right? So if I call collection, I should get the first array of 8, 5, and 3. So we have that. I call the remainder, it should be 100. Boom, it's 100, right? So what's cool is if I say math.min and I spread across my collection, I get 3. So it's going to do that for us. And so the reason why I think this is really powerful for us is because this is kind of like a little more declarative, right? When I say declarative, it means that I'm kind of, not really caring about how you solve the problem. I'm just saying I want this thing done. I want to get the smallest value. I'm not describing how I would get the smallest value. I'm saying, boom, math.min is going to give me the smallest value, right? So here I have smallest number now. Smallest value should be 3. Cool. So if I exit, my remainder should be, if I can do math correctly, should be 97. Cool. And now our collection should be 1, 9, and 11. And our smallest value, we declared it here on line 31, should be 1 now. And it is. Sweet. That's working, right? And so now if I do remainder, I totally spelled everything wrong. I'm so sorry. 96, right? So this is kind of like what we're doing. And so now if we kind of exit out of here, it gets mad because our test took too long to run. Mocha is only going to run our test for like, I think 2,000 milliseconds. And then it's going to be like, forget it. But this should pass. Cool. Awesome. So that is the spread operator. Now this is working. Can we get it on one line? You don't always have to get it on one line. I'm going to kind of let you be the judge here. But one thing about like declaring the smallest value is that it reads like really, really nicely, right? But one thing you could potentially do is say something along these lines, right? So let's just return this. Let's see if that works. Looks like it works. Cool. Let's make it even smaller now. And now, let's see if that works. And it does. Cool. Awesome. So we have this now. That works. Any questions so far with what we did? Feel free to ask them now. To all 5 viewers, I appreciate you being here, by the way. It's really cool that you're here. Feel free to follow if you're into this. I'm thinking the next one we do would hopefully be like an introduction to React, which I think might be really, really powerful for some folks who are like, oh, this is cool. I actually want to build something. Maybe the next one will be like an introduction to React. Cool. We're looking at elements. We want to grab all the second values and add them together, right? So const results, elements, We're going to reduce over that because that's what we're doing today. Everything we're doing today is reducing. Our initial value is going to be what? It's going to be, I think, just 0, right? Because we're not going to be really adding anything. I could leave that blank, but let's do that. And here, I'm going to say the sum, and then the next value. Right? I'm going to keep it on one line because I'm feeling good. We're going to say sum, and we're going to add the, really, it's not a next value. It's more a collection, right? So we're going to say collection 2 or 1 because we want to grab the second value in the array. And like we said, like, hey, the value or the array only cares about the index position, right? So 0 would be the first, which would be A. We don't want A we want 1. So here we're going to say give me that value, and let's just take care of that. So let's see if this works. Cool. Let me clear this. Let's type that. Cool. Cool. So that works. Awesome. So we are going to divide 560 by a ton of numbers. So Clay asks here, how did you get the math.min versus a sort? So sort's really cool because like you can use sort, right? But one reason why I did not decide to use sort. You could definitely use sort here on, so if we go back to this right here, it's a great question, Clay. Is that the result, or when you use sort is another array prototype method, right? So what you're essentially doing in that instance when you are sorting it is you're looping through another array, right? Which is technically not as efficient. So if you go with efficiency, right, all I'm really doing, I mean, technically I'm sure under the hood the spread operator is using some sort of like iterator, but this is going to be, from my understanding and from my own opinion, I believe this is going to be a lot more efficient and a lot faster and a lot less like how do I say this? A lot more explicit, right? Like I think a sort tells you that you're sorting something and putting them in an order, but math.min just says I'm looking for the smallest value, right? So it's just kind of like how you can use like rad as a really like an adjective, right? To describe something, but then you can probably use a better word than rad to describe like your excitement, right? So I feel like this here is a little more explicit in terms of like how you solve the problem. Hope that answers your question. Feel free to keep asking them if you have them. Cool, so that's working. Let's go ahead and divide this now. I know some of you are probably like, man, this is too easy. Don't worry, I got a couple of fun ones at the end here. I think it'll be a little fun. So let's do this now. We'll say const results. Oops, that's not right. Const results, and we'll say numbers reduce, and we're gonna kind of set it up one more time. So here our initial value is going to be 560, right? And what do we want to go over this, and this is going to be our remainder, right? And then our next value, and what we want to return. It's not a remainder. This is a, what is it for division? I don't know what it is for division. If anybody knows up there, we probably should change this to something a little more explicit. I don't think it's remainder. If you know what that is, let me know. I forget. Taco. We'll call it tacos for right now, right? We'll say tacos. And we want to take the tacos and we want to divide them by the next value. It's going to remain tacos until somebody tells me like what it actually is, because I don't really know what the word for division is. Cool. Let's fix it. Anybody know what it is? Nobody knows what it is? Alright, we'll come back to it later, but that works. All right, cool. This one's fun. So what's really neat about reduce is that your initial value can kind of be whatever you want it to be. It can be an object. It can be a string. So far we've been using a lot of like numbers, right? A lot of numbers. But now we can actually go ahead and try to use something that's not a number, right? So we're going to use a string. So we have a saying here. And what we want to do is capitalize every word that is fish or blue, right? That's what we want to do. So that's interesting. How are we going to do that? So we'll say const results, right? And we need to do some stuff here. Do the things, right? What we need to do is we need to somehow make the saying iterable, right? Right now I can't reduce over a string. If you look at what reduce says, I can only reduce over an array, right? An array. So like if I am trying to reduce over a string, it's simply gonna yell at me. So that's not gonna work. So we need to make it iterable, right? Once we can make the string iterable, we can use reduce to reduce over our string. Cool. So once I'm reducing over it, I want to take the current word, word, and check if it's in the keywords array. If it's in the array, then I want to upcase the word and then add it to our accumulator. If it's not there, just add the word, right? That's what we are trying to accomplish here. And this is why it's really, really important, I think, to like kind of say what you want to do in English before you just like, let's start getting at the code, right? Because it's not really smart. So I think that's probably the best way to kind of break down this problem. So the first thing we need to do is we need to make the saying iterable, right? So if I said like const, well, let's just say results for now, and then we can like, well, it might be better for you to see it. So we'll say like const word array, right? So there's a thing in JavaScript called split. So if I say saying.split, we split on the space of the string, what it's going to do is it's going to create an array of words that are split by that split by that character. So that's probably the first thing, right? So if I put this in here, let's see if this worked. Let's see if this worked for us. If I call the word array, 1 fish, 2 fish, cool. So this is exactly what we want, right? We want to like make our thing iterable. So that is working for us. Cool. So boom, done, taken care of. Once we make the string iterable, we can reduce over our string. So let's do that. So I'll say const results equals word array dot reduce, right? Now I'm reducing over it. Now, one thing I want you to think about here is what are we going to have as our initial value? I think our initial value should be an empty string because we're essentially making a new version of that empty string, right? Cool. Cool, so we've done that now. We can get rid of this. Cool, so let's do this. This is the rest of our pseudocode. I want to take the current word and check if it's in the keywords array. So let's set that up. So here I'm going to say this is our phrase, right? Our updated phrase, and then this is our word, right? So I want to take the current word and check if that word is inside the keywords array. So what we're kind of doing here is we're basing what we want to do off of a condition, right? So we could do like an if statement, but I don't know if I want to do that. I think it'd be better if we used like a ternary. So here, if I said, hold on, this is, yeah, I'll say here, do the keywords, it includes the word that I'm on, right? So if you don't know what includes does, this is something we got in ES6, which is super nice. And basically what it does is it asks the array, does the array contain this thing? Looking at the chat, Ivana just asked what kind of font I'm using. Let me get back to you. Let me see. I think let me get back to you. I really like it. I forget what it's actually called. Classic. Let me see if I can actually open up my font book here and find it. It's Pragmata Pro. Right there. Pragmata Pro. That's the font I'm using. Sorry. Wanted to answer that. So cool. Includes is going to check the array to see if that thing that we're looking for exists in our collection. So I'll say includes. And cool. So here, includes, hey, does this array include 2? It does. So if we look at this array right here, does this include 2? It absolutely does. Does cat include that? So it's going to return a Boolean, right? Whether or not the thing we're looking for has that. So we could write an if statement, but what's really nice about a ternary is that it like kind of keeps it small and short. So the syntax for that is the Boolean that you are, or like the comparative statement that evaluates the Boolean on the left, right? And then what you want to do is say, cool, like option, if this is true, right? If false, basically. So on the left side, this will be returned if it's true. This will be returned if it's false, right? So we said here, I want to take the current word, check if it's in the keywords array, did that. If it's in the array, then we want to upcase that word and then add it to our accumulator, right? So what I want to do here is then I can say, I'm going to use some grave marks here. I'm going to take what's currently inside of my phrase and I'm going to add to it my word, and then I'm going to, I think it's to uppercase, I believe is the function we're going to use. We're saying, cool, take that word and uppercase it. And then the next thing I want to do is if it's false, right, I'm going to do something pretty similar, but just say, give me the phrase, and then just add the word to that phrase, right? Cool. Let's see what happens. I'm curious. Gets mad. This is the best part about coding, though, is that if we are wondering what's wrong, we can just run the test and read the error. So let me do that. Oops. npm test reduce, and let's see what it says. Const results. Did I spell something incorrectly? Duplicate results. So there are more than one results, and that's line 58. That's why. Cool. So let's go back here, and let's run it again. Let's say now. Const results. Let's read the error. A file. That's not really helpful. Not really helping me. I think I have a syntax error. So let's look through. That's good. That's good. That looks good. Word array. I don't know. Anybody spot the syntax error? Oh, cool. There it is. There was nothing wrong. It was just not saved. All right. So if we look at what it says here, if we run the test and look at the error, this is exactly what we want. But if you notice, right here, make that bigger, there is a space. There is a space right here, and it's mad about that space. So all we have to do is trim it. And that should pass. Cool. Any questions so far? That passes. That looks good. We have one more test to do. But if you have any questions, please ask them now. Cool. I'm just going to wait. I'll keep an eye on that. But I think it looks good. I can't really think of any other ways to refactor right now. So if you have any other suggestions on how to do that, feel free to add them into the chat. Let's go back here. Cool. Now I want to find the smallest key. So here we are given an array, or not really an array of objects. This is just objects, right? Or we'll say like key value pair, right? This is just a key value pair. We have A, B, C, D, and then we have respectively on the right side the value of that key is going to be 100, 200, 300, 600, right? So what we want to do now is figure out a way for us to reduce over this and get a new object where the key is A and the value is 100. So what we're going to do, what I'm going to do, I think the best way to do this is to use reduce. Not really the best way, but like for this exercise, I'm asking you to use reduce. So here, the thing that we're going to run into though is this is not iterable. I can't loop through this with reduce. I have to somehow turn this key value pair into something I can loop through, right? That's what I want to do. So what we can do is there's this thing called object.entries, right? So if I say object.entries, what's really, really powerful about object.entries is it allows us to kind of like take these and turn them into arrays of keys and values. And it's going to be a lot easier for us to like iterate through and move through. So the problem we're dealing with is that this is not usable, but this is usable. And so with the object.entries, what it allows us to do is it turns the key value pairs into pieces we can use. So what I'm going to do here, ooh, hold on. I want my tmux. Oops. Cool. Is I want to make some entries. So I'm going to say const like entries. I'm going to say object.entries, right? And I'm going to pass through the key value pair. Key value pair, right? So I have my entries now. And then I'm going to say const smallest value. I'm going to reduce over that. And we're reducing over that. And our accumulator is going to be an empty object. Okay? That's what we want to do. Now, I do know I could probably just say instead of smallest values here are entries here. Oops. Smallest value equals entries.reduce. Is I could probably just say in here like object.entries key value pair. I could probably just do that and it would be like a lot easier, but if you're learning, this probably makes a lot more sense to you. So we're going to keep it like that today. Got my entries. I know I'm going to have like here, what if we called it like our, we'll call it smallest, right? And then here we'll have our like array of key value pairs, right? But what's really nice in ESX is we can destructure that and I can say like key and value, which is super nice because now I can just kind of iterate that way. And so what's cool is I'm going to throw an eval locus here. And let's just return smallest every time. So I call key, it should be A. Call value, it should be 100. I call smallest, it should be my empty object, right? I hit next. The next thing that we're dealing with now, key should be B, value should be 200, so on and so forth. The smallest should still be that accumulator, an empty object. So if we're thinking through this, I want to check the current value and compare it to the value inside of my accumulator. If that value is greater than or less than the greater than or equal to the, if the current value, let's say that, and maybe we'll do that. Let's change this from value to current value because I feel like that's a little more explicit. Current value, right? If the current value is greater than or equal to the smallest value, change the value of the accumulator to reflect the new smallest value. Okay, so that's what we want to do. Now the problem we're going to run into right now is the value is going to be really difficult to like get out, right? So like here, if I say eval locus, right now if I call smallest, there is no value in there, right? And I call value now, it's 100, so I can't really compare like an object, an empty object to that, right? And really like I don't really want to use like undefined. That's gonna be really hard. So what I would rather do, so right now if I say object.values, and what's really cool about object.values is it's gonna grab all the values out of an object for you, and there's only really gonna be one value in this object at a time. So if I pull in smallest, it's going to give me an empty array, right? So I grab the 0 out of that empty array. It's going to be undefined. Now that's not really cool. I think it'd be really cool to say like if that is the value of our accumulator, we know we're starting. So I'm going to say you're going to compare yourself to yourself. But if there is a value there, if there's a truthy value there, then stay there. Be yourself. Be like if you're 100, then be 100. If you're not 100, like you're either or. This is what we would call the or operator. So if this is a falsy value, we'll default to what the truthy, like the fallback statement is going to be, right? Like, hey, like if you're not passing me anything or aren't giving me anything, your value is going to be whatever, like this starting value. So here, it might make sense to be like, we'll say like let smallest value equal object dot keys, pass in the smallest object, we'll get 0, and I'll say cool, if there's a value in there, be that, but if you are not a value, then I want you to compare yourself to our current value. Okay? Cool. And what's nice about this is now we can say return our current value if you are smaller, less than, or equal to our current smallest value that's in our accumulator, right? I want you, if that's true, I want to take that because that is our smallest value, and I'll say, cool, this is our accumulator, key, and current value. And then If that's not true, meaning the value that we're currently on is bigger than our smallest value in the accumulator, then I just want you to return smallest. Okay. And let's go ahead and make that a little more legible. Cool. Let's see if that works. All right, let's see. Oof, hold on. I closed it out. My bad. That's what happens when you're don't know what you're doing. Iterm. Let me see here. Sorry about that. I don't know what happened. My window closed. JS enums. Let's try one more time. Actually, all right. Do this. Dot. We'll go back into the reduce test and let's see what happens. Sorry about that, folks. I want to see what the error was. Boom, it's mad. It's okay. Oh, it looks like a syntax error on my part. Classic. Let's go here. I don't want to print, dude. Why? Cool. Cool. So that's that. Oh, current value is that, and then if you're not that, then we'll say smallest. Cool. I think that'll work. Cool. Syntax, man, the worst. So let's kind of walk through what we just did. And it might make more sense to kind of debug as we're going through, because I feel like that might have just been like over some people's heads, because I know when I was solving this problem, that's initially what was going on with me. So let's just kind of talk through what's happening. So if I call smallest value right now, if I call smallest, it's an empty object. If I call key, it should be A. Current value should be 100. Okay. Now the problem is I just want the value, right? I want the value out of my object. So right now if I call object, and maybe not keys, it should be values. Might make more sense. If I call object.values smallest, I get that. I get an empty array because there's nothing in there. So that means I want my current value to be compared to itself. So we'll say current value. So if I exit out of this now, our smallest value, or what's in smallest, should be that A 100, right? Our key is B. Our next value is our current value, which is 200. And what I'm saying here is I'm saying, hey, grab the smallest values, right? So I'll say object.values smallest. It gives me an array. I'm like, cool. Let's grab that out of there. Is that there? That is absolutely there. That's not a falsy value. It's a truthy value. So our smallest value is going to be 100. And our current value is going to be 200. Is smallest less than or equal to current? That's true. Or that's false. Right? So if that's false, we're just going to keep our smallest value, which is 100, and so on and so forth. So this kind of keeps going on, right, until it finds that smallest value. So that's kind of what this loop is doing here, which gets this test to pass, which is what we want. Cool. It is 7:03. It's been really cool hanging out with you. I want to kind of spend the last kind of moments I have with you here just to kind of open up the floor to questions. If you have any questions, about today's session, about maybe what you'd like to cover next week, if people want to come next week. Let's go ahead and kind of leave that open right now. So if you have any questions for me, anything you want to say, please drop those things into the channel. I'd love to answer them for you. Also, yeah, leaving it open. Any questions? I know some of you are like, I want to ask. Just go ahead and ask them. There's no such thing as like what's it? I mean, anything related to this, I'd love to answer. If you have any questions, any clarification I can give you, please, go ahead and drop them into the chat. Quiet crickets, man. There's crickets in this channel, in this chat right now. Okay, well, I'm not getting any questions, so I think I'm just gonna go ahead and call it. Let me put one more time. Last call. Okay. Clay finally came up with one. Destructuring practice. I think the easiest thing for me that I did is I just kind of hopped into here and just kind of played around with it. So like made a function, so like const log me, right? And so cool, if I had like A, B, C, D, well actually destructuring, not spread operator. So if I said like, yeah, const log me, right? And I was like, cool, I'm going to pass you an object. So if I called it like an obj, and I was just like working with that here, I would probably just throw a debugger in here. And then I would say log me, and then pass it an object and be like like location Colorado, food, tacos, because tacos, who doesn't like tacos, right? Let's just keep that there for now. And what's really neat here is when I do this, I'm now going to be inside the like code itself. I'm going to be able to poke it, right? So if I call obj, the parameter I receive is that object I passed through. Now I could be very, like in a very small sense, be like var location equals like obj.location, right? Call location, have it now. Ooh, wait, location is, I just realized, a reserved term. So that's not a really good one, but I could say var food equals object.food, call food, get the tacos, right? Like that's cool. But now I'm just going to have multiple variables that I've just declared that are like very much similar to the keys that I've already made, right? So the best way to do this, if I do this again, and I make one, and instead of saying location, I put like place, right? And I was like Pokemon, course, Charizard, right? Logged it, go to the object, it's there. I could just say place food Pokemon and just be like obj. So now when I call place, oops. Alright, debugger's being lame, so I'm going to change this from a const to a var. Call place, get place, call food, get tacos, call Pokemon, get that. So that's really cool. I get those pieces now, right? Get them out of the variables. So I have those variables declared for me. Now I'm going to take this a step further now, and I'm going to refresh it. But what I'm going to do different about the log me function that we did in the past instead of saying this, I'm going to destructure it as it's coming in. I'm going to say place food Pokemon, right? And then now I'm going to pass it in very much the same way. Now instead of explicitly pulling those pieces out, I can just say place food and Pokemon, and they've all kind of come through the function, and the variables are automatically pulled out when we're coming in. So that's like really, really powerful from like a programmatic standpoint, when you're not having to like constantly declare or define the same variables. You can just kind of pull them out of the object already. So that's kind of what I did to like help me out with destructuring. Cool. So if there aren't any more questions, I'm gonna close it, but I'm gonna put one more call out there. Last call. Last call. Well, cool. I just want to say thank you so much for tuning in. This is a lot of fun for me. It's like therapeutic almost. To just kind of like go through programming, small exercises like this. So if you're into that, go ahead and hit me with a follow. I'm gonna try to do this every week. And if you're interested, please feel free to come and join me. Feel free to tell your friends about this if they're into programming as well. I'm thinking next week maybe starting some React. So if you're into React.js, I want to learn about React.js, I'm going to go and just start building a small to-do application. So if you're into that and want to learn that, come through. Thanks again. It was cool hanging out with y'all. I will see you next time. Later. Oof.